Consider the following formula. If A is equal to 2 and C is equal to 10, what is the value of B? To solve this question, we're going to need to substitute the number 2 in for every value of A and the number 10 in for every value of C. From there, we can simplify to find the value of B. So let's start by doing those substitutions. Here I have C, which I know is equal to 10, so I can rewrite this as 10 times B. I'll go back and write that in blue later. Minus 3 is equal to 50 minus B plus A, which I know is 2. So I'll write 2 times B plus 1. Then I'll go back and make those B's blue so that they're easy to see. So the goal is to get all of our B's combined together so that we can get them on one side of the equal sign and have our value be on the other side of the equal sign. That would be our answer. So now let's start simplifying. The first thing we should do is distributive property. Here we got a 10 outside of the parentheses, so we can distribute it or multiply it into both numbers inside the parentheses. 10 times B will give us 10B. Then 10 times negative 3 will give us negative 30. That will be equal to 50 minus B plus, here's another place that we can do distributive property. 2 times B will give us 2B, and then 2 times a positive 1 will give us a positive 2. Now we need to keep getting rid of these parentheses, so let's combine our like terms. We have a B and a 2B. If it exists in math, there is always one of them, so that's the same as a 1B plus 2B, which would give us 3B plus 2. And then everything else can come down from the first equation like so. And now we can continue to simplify. Again, in math, if it exists, there's always one of them. So this negative sign is really a negative 1 out in front of this set of parentheses. And that is a number we can distribute into the parentheses to get rid of them. Negative 1 times 3b would give us negative 3b. A positive times a negative is always going to give us a negative. And then negative 1 times positive 2 will give us a negative 2. Again, bring everything else down from up top. And now all of our parentheses are gone, which means we can do opposite operations to isolate our variable b and find its value. Let's start with this 30. 30 is being subtracted from b, so the opposite would be adding it to both sides. These 30s will cancel, leaving us with 10b equals 50 plus 30 is 80, minus 3b minus 2. Now we have some like terms on this side of the equal sign that we can combine. 80 minus 2 will give us 78 minus 3b. Now 3b is being subtracted, so we need to do the opposite and add it to both sides. These 3b's will cancel, leaving us with 13b is equal to 78. Now I'll bring this over here since we ran out of room. The last step here, 13 is being multiplied to b. So to isolate b, we need to divide both sides by 13 because that is the opposite of multiplication. 13 divided by 13 just gives us 1, which leaves us with b equals. Now I don't know how many times 13 can go into 78 offhand. It's not a common multiple we work with. So let's see if we can use process of elimination to help us solve the rest of this problem. I know that two-digit numbers times two-digit numbers will almost always give us a three-digit number, right? Because the smallest two-digit number that exists, 10 times 10, will be 100. So if we use bigger two-digit numbers than that, it will be greater than 100, and therefore greater than the number 78. So that eliminates both answer choice D and answer choice C. Those numbers are too big. Then if we look at A, 2 times 13 would be easy to do. 2 times 3 will give me 6. 2 times 1 is 2. 26 is not 78, so it cannot be answer choice A, and by process of elimination, it is answer choice B. If you really wanted to check and make sure that that was correct, you could try 13 times 6. 6 times 3 is 18. 6 times 1 is 6, plus 1 is 7. So we know that 13 can go into 78 6 times, making B the value 6.